Hello and welcome to a new session. Today we are going to be talking about information visualization. Then let's start about our learning objectives are going to be to discuss the best practices when we want to visualize health data. And in order to do that, we need to go back and remember this information cascade. When we are talking about information visualization, we are trying to preserve this cascade and taking that data and creating meaning and make the people be able to have a proper interpretation of what is being presented to them and be able to create some knowledge. And eventually, with that knowledge, we are going to be able to create that decisions or create wisdom. But the main focus of the visualization is going to be enhancing the process of translating data, creating meaning, and creating some information that is going to be useful to do something in context. Then if we talk about information visualization, basically is the process of creating interactive visual representations of that data. And the thing that we want to use exploit the perceptual and cognitive capacities of us as human beings in order to solve problems. And in that regards, when we talk about information visualization, we are talking about an interactive interface of data that is going to increase that cognition, or is going to increase the perception ability of the individual that is interacting with the data in the way that is presented. And what we want to do is transform data into an image that is going to help that interaction and manipulation of the user. The purpose of having visualizations is uh, ultimately is to create an insight about the data, about the possibilities that exist in the world. And we need to understand that different visualization techniques are they're going to have different outcomes or different results and different understanding, and that's where we need to start developing a skill how to choose properly the best visualization to the type of message that I want to translate. Then visualization needs to provide a mental model of the information of the data, and that's why the visual user interfaces are going to support that. We want also to explore and understand patterns in the data that is presented, or we want to communicate important aspects of your data set, or you want a graphical representation that conveys complicated ideas in a way that is more clear, precise, and efficient. At the end, these are graphical depictions that are going to be more easier to understand. Remember that an image is worth 1,000 words. And when we talk about this information visualization, about the visualization about the insight, what is the meaning, what is the message, and we are not focusing on the numbers. Okay, then, and the main goal of this is to discover, make decisions, explain phenomenon, and ultimately what we want to is communicate in a way that is understandable and be able to analyze, explore, discover, and illustrate in a specific topic. And if we think about this, information visualization is really helpful when we are monitoring, for example, large amounts of data in real time. An example of that, remember when we had COVID, that we have this dashboard that allow us to see how things were going on, but it's not the only application. But remember, raw data is that way that we receive the data and we collect or measure the world. It comes in many ways. It comes in questionnaires, interviews, observations. It could be analysis of documents. It could be web scraping, that we have a software that is bringing data from internet. It could be matching measures, and it has different flavors. And we always have that problem of, okay, we collect the data, but how we are going to store. Traditional ways of studying data is through databases, and the main concepts that we need to be familiar and understand and how we relate with them are the tables, a relational model that allows to link tables, concepts like objects that are abstractions of the physical objects into uh, uh, data representations or computer interpretable representations. And we also have hierarchies that are like the folders in your computer, or ontologies that are basically uh, language networks that we can have about concepts. Let's talk a little bit about these data storage models that we use, and we are going to be focusing in the tables, the relational model, and the objects, because they are the most common ways of accessing data. Even though we are going to have hierarchies, ontologies, and semantic networks, it's not the common way that we are going to be interacting in data in healthcare, even though that's going to maybe change in the future. But let's focus in the most common ones. Then the table is really simple. No, we can it's like the Excel spreadsheet, or the or different other tables that we see there. And there are two types of tables. It could be column oriented, or it could be row oriented. And sometimes they are like short or long representation. And if you see in column oriented, then every single column is going to be a variable. In this case, we have three individuals that are represented in the individuals on the row, but the data it's in the columns. That's the column orientation, because ID, gender, school, math, science, history, that those are going to be subjects, are in columns. We can have a row orientation, and as you see, we have individual 1, gender M, school West, subject math, score, and this is useful in some transactions, but is really inefficient in storage. Okay, then we need to really understand what is going to be the representation, and in the future you will gain more insights when you really want to have a long representation, that is the row oriented, or the standard or more common representation, that is the column oriented. But most of the time we are going to be using column oriented data, and most of the applications, software, and tools that we are going to be introducing in these sessions, usually they are going to be using the column oriented way. The row orientation is going to be useful in specific ways of visualizations that that require that the data is reorganized in that way. The most important thing is remember that the most common is going to be the observations in rows, and the data are coming in columns, and that's the way that we usually do that. But you need to be sure that each variable is going to be in a column, that they are going to have the same data type and the same units. No, it's because, for example, you have the glucose, and glucose can be measured in different units. You want to be sure that the unit that you are capturing is the same from the different data source. If not, you need to do some transformations to make that work. And each observation, then each individual or things that we are measuring, is going to be in a different row. And if you have more than one type of observation, then maybe we are going to need a new table. And that's when we are going to have that need of the relational model. And for example, you have multiple tables, then at least you need to have a way of joining them. Then the relational model is the one that solves that problem. Allow us to represent data in a different way, and actually is highly efficient in storage when we optimize them, and is highly efficient in retrieval. That's the intention of the relational model. And for example, here we have the different schools, and then we can assign we have the different schools, and then we can assign students to the schools, and we can have particular information of data about the students, and then we can have classes in a different representation, and now we have that long format table. We have the student, the class, and the grade, but then we can use all these relationships to try to understand different things, and we can have queries. Hey, give me the average of math. Then in that way I only pick up the in this table the class IDs for one, and I can average them easily. Or hey, give me the average for student one, then I know that I just use student one and do average here. Or I can make queries like, hey, what is the school that has the best performance? That's going to be a little bit more complex because I need to come, hey, what are these students, and where the student is taking the class, for example, is not being represented in this relationship. And that's telling us, oh, maybe I need an additional table to answer that type of question. Some of the tools that we are going to be learning to use, they are capable of creating relations and handling relations, relationship models in order to process the data. Nowadays, we also find the object oriented model, and one of the most common representation is the JSON. Is a notation that's inspired in Java. In this case, we can see how we create a collection of schools, we create a collection of classes, and we create a collection of a collection of students. And every single student is going to have an ID, a name, a gender, and then I can say if attends one or more school and what is going to be those grades on the classes. And this student, for example, Noah Kim is attending 2 schools, and then we see the different classes. In this representation, we are still missing, hey, where are those classes being taken on? Because we didn't fit that in the model. These models, they may be more lengthy. They are single files, but they have really interesting applications, especially when you want to have patient-centered data. Then your patient is the is the object, and you don't have all observations for everybody, and then you are going to have gaps in the tables, and then the object oriented model, so you don't anticipate the things that you are going to measure and you can add them on the fly. Then those are applications where the objectful approach of data storage are useful, or when there is not really good standardization across different things, and it requires a little bit more computational power in order to extract the data and be able to represent. But it's going to be common that you are going to see this data format, and it could be also XML. XML is an excellent way of representing objects, and it has been used a lot in healthcare. Indeed, there is an international standard of data exchange, that is the ODMC disk, that allow us to exchange data across different systems, and there are a collection of standards in this library, but this is the one that is used a lot in clinical and translational research, and it's pure XML, and is really flexible because we cannot anticipate all the fields that we are going to have in a particular table, but we can agree how we are going to organize the data. Then in this case, we have studies. The studies are going to have patients. The patients are going to be encounters. The encounters are going to have the data. And that's the way that is structured the model. Then going back to our discussion, then yes, we are going to have data in so many ways, and then we need to really understand how the tool that we are going to use has the data, and what can we do with that data and what we cannot. But in reality, having tables, having those representations, those things are really difficult for humans to interact. Then we need to transform those in better ways. And as you know, information is now essential part of human life. And if you think about data and information is kind of the new gold, the new oil, because there is value there, and people is really eager in collect data, be able to manage data, be able to draw conclusions, and you can create narratives. Remember, we have discussed that we can tell stories with data, and that's a powerful tool. Then extraction of that valuable knowledge from the data is still a big problem, and that's what we try to solve. And how we really bring out the really important thing that we want to see, and how we highlight those things. Then for that, there is a proposed process or or approach where we want to map the data. Then basically we take that data and transform that into a graphical representation. And we are going to be exploring some of those representations and how we do that. Then we need to select the actual data that is going to be useful to given task or job to answer the question that we want, because we don't want to have everything there. We can confuse the users presenting all the tables, all the data that we have. The presentations is basically how to manage the different visual elements in the screen. And usually the best way of doing this is as a funnel. You start with a general idea, and then you are going drilling down. That's part of the features that we have explored in previous presentations. Now you want to enable users to explore and be interactive. And of course, we want to consider the human factors. Usability and accessibility are going to be really important, especially in the visual domain. The use of colors, and if the colors are conveying meaning, you need to be mindful of that, because remember that not every single human has the same perception of colors. And at the end, okay, we need to evaluate all this process to see if really the goal that we have has been achieved or not. Then this kind of the stakeholder process, but let's focus then on mapping. You may have seen this graph before, where the first question that you need to ask is, what do you want to show? What is the message that you want to convey? Do you want to show relationship between variables, or do you want to compare them? And that's a really important distinction, because relationships is when they go together, and comparison, maybe they go together or they diverge, or there is something that you want to highlight in that parallelism of that one or two or more variables that you want to compare. Sometimes we just want to observe how the phenomenon is distributed respective to another variable, or we want to see the different parts, the different components, the composition of a phenomenon, and is when we want to use those composition. Then this little chart of WHO help us to map those basic visualizations that we can use for a specific data. It's really important also to understand that this can apply to numeric data, and when you have categorical data, and when you have ordinal data, you need to be careful, because not always you can map them directly. There are some graphical representation that necessarily require to have numeric data, while others can be resilient to use qualitative data, ordinal data, or categorical data. And you need to be really mindful, because sometimes you have representations of data that are numbers. Then you have categories. Then you have, for example, the color of the squares in a chessboard. Then you have white and black, and you can code them as 1 or 2. And actually, the tools are going to receive 1 and 2, and they are going to try to do mathematical operations in 1 and 2. But you need to be mindful that 1 and 2, they are just labels. The 1 and 2, the quantity doesn't have any meaning. There is not meaningful that 1 is less than 2, because actually in that chessboard, whites and black, they have the same equivalent representation. Then it could be X or Y, it could be 1,000 or million. It's just a representation. You need to be mindful of that, because computers, AI, and tools, they don't know that distinction, and they are doing whatever you tell them to do, but you are the one that needs to be the brain that is, hey, is this really a numeric variable, or those numbers are representing something that is not really a quantity but is more a category. And sometimes we have a special category that is the ordinal variables, where 1, 2, and 3, they represent a sequence. Like, for example, the level of education, then 1 could be elementary school, 2 could be high school, 3 could be college, 4 could be a postgraduate, and then you have some meaning there. But the scale maybe represents not a linear gain of knowledge, but at least that you are accumulating more knowledge, and then you can take advantage of that order to represent things. But remember, a lot of times we have the missing value as 99. Then is missing value as 99 really meaning that is more than the other ones? Then those are the type of questions that you really need to ask yourself when you have that data and try to represent that, because you can induce a lot of errors, or you can get confused when you are not mindful of those differences. And also we can think about this, about the functions of visualization, and we have introduced this. Then distribution is the most basic way of describing variables, how they are distributed, and you can have among groups, or against time, or against other variable. What are the correlationship? Are they growing together, or going apart? Are they going in parallel? Are they not related at all? Then those are really important ways. Ranking, what is more than the other one? Yes, what has more observation, what has more weight, what is more important. As we mentioned, part of a whole. What is the structure of this? What is the subcategories, the sub elements, the drilling down that we can have there. The evolution, usually it relates with time, no? How time affect the presentation of the variable of the observation, or how events are going to modify the outcomes or the of the observations that we are having. Map, and now we have the geographical representation, and we're going to have a whole dedicated class for geographic information visualization and flow, how things changes about the states, time, conditions, and things like that. A really useful tool that I briefly introduced in the past, but I'm going to explore a little bit more today, is this periodic table of visual methods. And if we go to the web page, it's kind of interactive. Today, since we are talking about information visualization, it's kind of the center here of the periodic table. And if you notice, when we hover, we are going to have really cool visuals that are telling us. The other thing that you need to think is, if you want to show a process, or you want to show a structure, and that's how the colors work here. Or you want to have an overview, or you want to have a detail, or you want to have both, because you can have detail and overview combined, because you can do drill down, or there are some capabilities. Do you want to have a divergent thinking? And divergent thinking is a mode of thinking in which a person can create other responses or think more about what is going on. It's like a do your interpretation. Or convergent is try to make complex things be more simple and try to create that synthesis. Okay, then these are really cool properties of the different visuals that we have. And starting from basic representation, then this is a convergent thinking that is an overview, and it's a structure visualization. Then basically is how you put this visual that has a lot of text, and you go from left, right, and have different objects. As you see, tables, these are not numerical tables, these are tables of text. Okay, that are valid as well. They are they have properties and the structure, because you can see the columns and the rows, and they have both the overview and the detail, but it's just an abstraction of concept, and that's a valid visualization. Things is we want to move away from words, no, and be able to draw conclusions quickly. Then, for example, radar. This is a really interesting visualization that we can use to have multiple axes in a phenomenon where every single line of those represent an axis, and we can have different elements that we observe. And the comparison we do is by the area that they're covering in the radar, and that's a general view of the phenomenon. And you can see, hey, there are things that behave closely, others that don't behave closely. And you see the red and the purple kind of behave in the same way, and the the yellow one is bigger when we don't really see the green representation here. These are the parallel coordinates, where you have this is kind of having this radar, but deploy in other dimensions, and usually we have this over time over a continuous variable that we can have, and every single line represents the additional variable over that observation of time or variability. The hyperbolic tree, it's a network analysis tool. In this one we have nodes and the relationships, but we can add additional nodes of the other individuals, and that's the actual network representation analysis. The cycle diagram, timelines. We are going to dedicate a little bit more of timelines because they are really powerful in healthcare. We have the Venn diagrams, there are concepts, the Sankey diagram. I really like the Sankey diagram, especially for system dynamics. And I did a small publication with some students that we use actually Sankey diagrams to look the dynamic of patients in changing in the blood pressures over time. And in this particular visual analytics, this is a paper about visual analytics, we can see that it kind of preserves proportion in the way that people it changes from one group to another, and that generates a really interesting hypothesis that we want to explore. What is the underlying condition that you have kind of tacit probability of changing group that we are not really observing? Because here we have the different categories of blood pressure, if you have treatment or not, and over time we see that there is kind of a persistent proportion of change, and that was kind of an interesting finding that we had in this particular element. This is the information lens. It's a combination of a heat map and bar graphs, and you can do really drill rounds there. The entity relationship diagram, that's the one that we were using for the relational model of the tables. We have Petri nets, flow charts, and these are more for conceptual analysis. Here we have the semantic network that I already mentioned before, this data flow diagrams. Then these are more complex for more abstract elements. And of course, we have the tree maps and we have the data maps, really useful in healthcare. The infographic, the cartoons, the enriched picture, the maps, the learning map, and the infomural or the infographic. These are powerful tools to communicate with communities. We are going to see some tools that allow us to do that. These are other ways of representing data, and I invite you to explore all these. This is a really interesting guide that you can see the different visuals that we look, and what are going to be kind of the applications and good examples of them. Then let's focus a little bit in that concept that I mentioned, that are going to be the timelines and why they're so important. Because in healthcare, phenomena are not static. Even though we tend to do crossover observations in a period of time, it's really important to understand the dynamic over time. And a timeline is when we have time-related data, as they mentioned, and health changes over time. Then here it's a timeline about the earthquake that happened in Haiti, and the different moments and different interventions and who were interacting with that. But that's not the only thing that you can put in a timeline. That is time and events. You can actually start adding data to the graph. And here we can see that event A, B, C, D, E, and F, they are related with years, and they can have an observation about those events. As you notice, we can have two different representations of the same data, one where the years are evenly spaced, but they are not proportional space to the year, and there is another one we can use the actual distance of the years to represent the data. It depends what is the type of message that you want to transmit, that we use one or another way. Okay. I kind of always prefer to use the real scale to be more transparent in the communication. Sometimes you just want to associate the event with the magnitude, and maybe it's not critical about over time, but having the scale of time is really important. And you can fill the blanks with other colors and data, and then now you have a relationship and start to see some dynamics that are in the events. And then you can say, hey, maybe this event made the thing going down, and this other event continue, but maybe this one creating a peak or things like that. And this was a critical one, and something was changed. We need to analyze that, and something happened and things got worse. Then who knows, no? But that's part of the power of timelines in the relationship with events. The other thing is removing some scales can facilitate the reading, or we can also simplify the elements instead of having all the information in the x axis. We can just label the elements and see, oh, the dynamic is associated with events, and then we can start making the line graph the timeline itself, no? Not only the representation on the axis. Or even we can have charts like this, that we have the frequency of different variables, and maybe we modify the representation and how the individual changes from ranks, and or how the overall observation happen, and simplify elements. Or we can combine observations, and this is like that approach of the whole and the part. Then if the whole is going to be the 100% and how the parts behave over the time, then this is really a powerful tool to convey data in healthcare. And actually, if you want to explore a little bit more about timelines, there is an actual tool that you can use to make your own timelines and explore existing ones like this one, Women in Computing. And then we have the different events, and you have some infographics associated with the timelines and some additional information. But timelines are really, really interesting ways of telling stories. And healthcare have that particular dynamic that changes on time. Then it's one interesting tool that I invite you to explore. Another important representation that we use to convey a lot of information and data in an abstract way is the heat map. And this is an example of the events of infection diseases in the 20th century. We can see there when the vaccines were introduced, okay? And this heat map is telling a story, no? Hey, we did something in that period of time, and seems that things got better. And we can see how things got better until here. And we think, hey, what happened there? Maybe we need to update this heat map. And maybe an answer is going to be in a different data source that I want you to explore, that is about what is happening with immunity and outbreaks. Then this is a continuation of the data, and we can see how outbreaks are becoming more frequent since 2000. But it's because some policies in enforcement of vaccination has been modified, and then we start to see those peaks, and we can tell stories, and then we can bring attention from the public health perspective to where really is going. Now, maybe we cannot modify the behavior of the individuals, but data and visuals can tell the story, can help us to support that narrative. Maybe talk with the policymakers what we want to do. We also face challenges with unstructured data when we have unstructured text. And there are several ways of managing uh, this type of data. The most common way of doing this is, for example, doing a frequency analysis of the words, and then we create a word cloud. Or we have new natural language processing elements, but usually what we do is extract features, extract frequencies of words, and we are able to see, hey, these are the topics, these are the themes, these are the things that are happening, and we can represent them in magnitude, or even create infographics. And this is another interesting and cool tool that you can start using for free, that is called Infogram, where you just upload your data, okay, or you upload your chart, and then you can start playing with visualizations. And actually this one can create those word clouds. You can create word clouds, or you can have picture charts that are representing that data. And of course we have maps. You can create now the integration into infographic dashboards, instapods, or even creating other type of reports. And as you see, also we can unlock the power of AI when we provide the data. We create a prompt that is going to help us to try to convey that data, that information or that message. Be mindful that AI is not perfect. You really need to know your data. You really need to know your message to really be able to criticize the tools that you are using and the result that you are producing. Because remember, we can modify the interpretation of the world just with the way that we represent the data, just changing the scale or changing the hierarchy or presenting something that is not ordinal as ordinal can create misdirections. Then the most important reflection is definitely that information visualization is going to amplify our cognition. It increases our resources because it expands the working memory. We don't need to do calculations on our mind. We have something out there that is helping us to support that working memory. It reduces search because we can have high data density in small spaces, enhance recognition and patterns, because human factors, we are really bad in recalling things. But if you recognize elements, it's going to be easier. We can have perceptual inference because visual representations make sometimes obvious. And even you have small differences, when you modify the scale, you can amplify that differences and do the zoom in if it's necessary to transmit the message. We can have also perception monitoring, and is basically a monitoring large numbers of potential events in a single element. I show you all these composite graphs like the radar or the stack that can allow us to help us that, and we can have a manipulable medium that allows the user to explore that space and create their own conclusions. We have really challenges that they have been there for more than 20 years. We have challenges in usability, we have challenges in the different cognitive tasks and how we map them. There are problems with prior knowledge. Is the prior knowledge of the individual really going to contribute in interpreting the data, or is going to create different biases? Okay, and how we remove those biases when there are prior knowledge. The education and training in visual literacy that we have been discussing, that the quality measures that what is a good visualization, no? Because good is not really that is beautiful, it's not really that is enhanced, it's not that there are a lot of qualifiers that, hey, we want professional looking. What is professional looking really? What is the measure for that? Because there are tendencies, and sometimes tendencies we assume that that's the correct one, but maybe that's just the aesthetic that is predominant in that moment, but not necessarily an object measure. Scalability is, you see, these visualizations sometimes are really focused on making a more generalizable. They are not easy. Aesthetics, then what is really appealing, no? Because there are different concepts about what is appealing to some particular groups and not appealing to other ones. When they are paradigm shifting, and now we want more dynamic, more visual, more movement, but it's really the movement, the thing that is going to be conveying the message, and how we can create wrong representations and misunderstanding there. And how we create that causality, because relationship, remember, is not causal effect. We can say there is this event, and we see a modifying in the modification in the future data, but it's really a causal thing. It's an underlying element there. It's just a symptom, that event of something different. Then we can show the what maybe, but the why is really there. Can we justify that relationship? And there are challenges that are going to be specific for different fields, and healthcare is particularly challenging because accessibility, privacy policies, things like that, then they are going to be important to review. There are modern and new emerging challenges because technology has changed. The expectation of the public has changed. The way that we access data has changed. Then we create new problems. Then uh, we have emerging challenges in qualitative visualization and integrity because if we have generative AI and generating visuals that we introduce some tools for that, is that generative AI really consuming the data in the way that it is, or is just creating mistakes by the way that is designed and creating or making up data or making up information that is not really representing the data? Okay, and remember that we have deepfakes data, we have deepfakes things. Then now what is true is a little bit more difficult to really understand. What is the source of the data, how it's collected, how was that generated, and how it transparency is going to be really challenging and important in the future. That uncertainty in quantification, then users need to understand the risk and incompleteness of data that they are viewing, because uh, we used to think that data is complete, but remember that data is just collecting in one way. And nowadays that we have crowdsourcing, nowadays that we have patient reported outcomes and patient reporting data, now that we have data coming from the source, but they could be biased even the way that we select the individuals that are providing data. Then what are we missing? And what are the new biases that we are creating in the way that we are collecting data? Accessibility and inclusivity, then the audience again. Who are we talking to? Are we really providing solutions for the public that we want, and take into account the things that I have talked about, color blindness? Because yes, there are cool, really nice representations out there, but do they pass the test of color blindness? And if we want to explore a little bit more of domain specific challenges that are unsolved for visualization things, then I will provide you a link for a panel that happened last year in Eurovis, a conference about data visualizations, about what are the challenges in health data. As summary, then remember, define your task. You need to organize your data, select the proper visualizations, and define how you want to interact your users, and go there, explore, play, and we are going to getting close to really playing and creating our own visualizations. Thank you, and see you the next time.